Till now, we had a good discussion regarding thermodynamic stability. Now it is the time to discuss other kind of stability. It is called as kinetic stability. And kinetic stability deals with rate of the reaction, speed of the reaction. Kinetics related toward the speed. So in your syllabus, the point included, just wait, is different types of reactions. So let you know first different types of the reactions. In that, the first type is substitution reactions, about which we have to discuss in detail. Not both, but one of the substitution reaction we will discuss in detail. Substitution reaction. So two kinds of substitution reactions are there. One is nucleophilic and other, yes, will anybody answer?
Electrophilic.
Yeah, electrophilic. You might be aware about the name nucleophilic. Phil means that's a attraction, or they love the nucleus which is positively charged. Electrophilic, they love the electron, means negative charge. If I have to talk about the coordination compound, say Ml6, here two entities are there. What is first entity? That is a metal ion, M plus N. Let the charge on that metal ion be plus N. Positive charge, of course. What is the second entity? What is the second entity? In complex, one is metal ion. What is the second one?
Ligand.
Right, ligand. So ligand can be neutral or ligand may carry the negative charge. Doesn't matter, but ligand will be electronegative. So considering the electronegative aspect, polar separation aspect, we will consider ligand as negative and metal as positive. So if there is a reaction where substitution takes place of the metal, suppose substitution is of the metal, then that reaction will be nucleophilic or electrophilic. That metal is a electrophile or nucleophile. If it is a positively charged, yes please.
Nucleophile.
Nucleophile. See, what is the charge on nucleus? What is the specialty of nucleus? What is the charge on nucleus? Yes, please help me. Positive or negative?
Positive.
Positive. Charge on electron?
Negative.
Negative. So who will love the positive charge? Negative section. Who will love negative charge? Positive section. So metal ion will get attracted towards what? Electron or negative charge. Therefore, what we say, metal substitution is electrophilic substitution and ligand substitution is nucleophilic substitution. Are you understanding what I am saying?
Yes, sir. Yes, sir.
Yes. So let me give the examples one by one. The first example of nucleophilic substitution. So let me take one complex, say cobalt complex. Here ammonia, NH3 and Br minus bromide or bromo. These are the ligands and charge on this complex is 2 plus. And I want to substitute one thing.
Screen share नाही.
Oh. Then till now what we are doing? Just wait. Could you able to see?
Yes, sir.
So ligand, ammonia and bromide. Outside I am considering H2O because I am talking about nucleophilic substitution. Nucleophile means ligands do love positive charge. Therefore they are nucleophile. So substitution of ligand is a nucleophilic substitution. And the result of this reaction is CO, NH3 5, Br will get replaced by means of H2O. Charge is 2 plus Br minus. This is an example of nucleophilic substitution reaction. Is this example clear? If no, then say no, I will explain. Here say one mistake is there, here. What should be the charge in this complex ion now? Charge should be?
Positive.
Positive, or how much positive? 2, 3, 4. See this complex. Bromide carries -1 charge, ammonia carries no charge, and cobalt should carry how much charge? At least complete now.
+3.
+3. +3 charge and -1 charge. Total is +2 charge. My question now here is, what is the total charge? Ammonia is neutral. Water is neutral. Then what should be the charge? At least complete now. What should be the charge? Okay, what is charge written there? Tell me at least. No, where is the problem? I'm not understanding. What is the charge I represent there? +3. Yes, +3. How it came? Metal carries +3 charge. So +3 charge is there. Ligand carries no charge. Ligand carries no charge. So total charge is +3. That was expectation. Are you following what I'm saying?
Yes, sir.
then you should reply. Actually, not only one or two, everybody should reply. It is my expectation. And I said already, for this online lecture, it is not compulsion for everyone. Preferably reply. I understand everybody will not reply, but at least few students, if my expectation is wrong, then you tell me, don't ask any question, go on teaching only. I'll do that also. But be clear cut. Are you understanding what, why, and what do I ask?
Yes, sir.
Yeah.
Yes,
Yes,
sir.
sir.
Yeah, it is a nucleophilic substitution reaction where ligand bromide is replaced by means of water or substituted by means of the water. About electrophilic substitution reaction, if I have to give the example, then example let me consider in general a complex say Ml6. It reacts with one other metal say M dash and results a complex M dash L6 plus what should be there? What should be there?
M.
Right, M. So what is happening here? Previously metal in the complex was M. Afterwards metal in the complex is M dash. So M is substituted by M dash. So it is a substitution reaction. But what about the metal? Metals are electropositive, means electrophile, or they are nucleophile. Yes, metals are electrophile or nucleophile. Metal, positively charged species will go towards electron, will go to negative charge, or will go to positive charge.
Electrophilic.
It is electrophile. So it is an electrophilic substitution reaction. Previously I discussed nucleophilic substitution reaction. As per your syllabus, we have to discuss more on these nucleophilic substitution reaction. So SN1, SN2, such mechanisms we have to study. But now our role is let us know various types of the reaction. Now the second type of the reaction that I am informing, that's a redox reaction. First type, substitution reaction. The second type now, the redox reaction. Let me write here the reaction. Reaction or is a Fe. Okay, it's a iron cyano complex FeCN6 4 minus, which gets converted to FeCN6 3 minus. What is the difference here in these two complexes? Which metal ion is present here? What is the charge on this metal ion? Metal ion present is, what is the charge on central metal ion there in this complex?
+2.
Right. What is the charge on central metal ion in this complex?
+3. +3.
Right. Fe plus 3. It means ferrous gets converted to ferric through the loss of one electron. This is a redox reaction. Change in the oxidation state, redox reaction. So metal ion is undergoing the change. So it is a one kind of the reaction. The other reaction I represent where coordination sphere or ligands do undergo drastic change. Oxidation state is changing because there should be change in oxidation state. Without that, loss or gain of the electron will not be there. It gets converted to, I need your help now. Which metal ion is present in the first complex? Here, which metal ion is present? Where is the problem?
+3.
Yes, plus 3. And right side, which metal ion is present?
Chromium.
+2.
Right, plus 2. Chromium plus 2. So Cr plus 3 will accept one electron to produce Cr plus 2. There is a loss or gain of electron, means it is a redox reaction. This is also redox reaction where loss of gain of electron is there. So such reactions are possible. In this first reaction, what happened? Metal ion only change. In second reaction, what happened? Metal ion change. By the way, ligands also have changed. Complete reaction are not balanced. Only I want to give the important part of that reaction. Your ammonia will evolve, chloride ion separate will be there. That's a different thing. So along with the change in the oxidation state, the surrounding also change. Coordinating group also is change. So this is the second type of reaction. That's a redox reaction. What was the first type of reaction? What was the first type of reaction?
Substitution reaction.
Right. And the second type of reaction is a redox reaction. In this redox, further two different ways of the reactions are there. Those are discussed. In first way, only metal ion undergoes a change in the oxidation state. In the second way, metal ion of course will undergo change in oxidation state. In addition to that, there will be change in coordinating groups or ligands. Now let us know the third kind of the reaction. That reaction is isomerization reaction or racemization reaction. SATion or ZTion. just different isomers. So linkage isomers, that one of the type of the isomer that I discuss. For that I write the example. Let me consider cobalt complex, and out of the six, one of the ligand that I want to consider ONO. It is called as nitrito, ONO minus actually. Means it is equal to NO2 minus. So here there is a minus one charge. It has no charge. Cobalt is in plus 3 oxygen state. So charge on this complex will be plus 2. And it will result one of its other isomer. Charge will be same because NO2 minus or ONO minus. Charge is minus 1. So there will be no change in net charge on the complex. One may think, what's the difference in ONO and NO2? Yes, linkage is a difference. In this ONO, this ligand, this oxygen is a donor. Oxygen links to metal ion. And in this NO2 minus as a ligand, nitrogen is a donor. Nitrogen donates lone pair to the metal ion. Because of linkage is different, it is called as linkage isomer. Those are called as linkage isomers. And conversion from one isomer to other isomer, that is called as isomerization. Or geometrical isomers, if you think, then cis is one form. Cis isomer. It can get converted to trans isomer. So cis and trans conversion, it is what the isomerization process. Or optical isomers, if you consider, that's a dextro isomer will get converted to LEO isomer, and when they remain in the equal quantity, dextro and LEO in equal quantity, equimolar quantity, racemic mixture will be there. In organic chemistry, you might have studied all those. So all such kinds of reactions are possible for coordination compounds. So this is the third type of the reaction. First was substitution, second that already I discussed redox, and third is a isomerization reaction. So are these three types of reaction clear to you?
Yes, sir.
Now let us understand substitution reaction. Out of that substitution reaction, nucleophilic and electrophilic, I want to pay the attention towards nucleophilic substitution reaction. And this nucleophilic substitution reaction goes through two kinds of mechanism. One is called as SN1 and other mechanism is called as SN2. Then what's the difference in these two mechanisms? That SN1 reaction means the rate of the reaction depends on only one reactant. SN2 mechanism means rate of the reaction depends upon two species. It is a unimolecular reaction. It's a bimolecular reaction. So main thing is that rate depends on how many components, how many species. On that basis, one or two will come. In descriptive way, if I have to answer, then the SN1 is called as dissociative mechanism and SN2 is called as associative mechanism. The name itself says there is a cleavage or dissociation, and here name says there is a joining or association. Are you following what I am saying? No, students, you should reply no, so that I will understand. If no, then say no, no problem.
No, sir.
No. Okay, good. See, I am talking here substitution reactions. Out of the two types of substitution reaction, one is nucleophile and other is electrophile. I am talking here the nucleophilic substitution reactions. These reactions are of two types. One type is called as SN1. Second type is called as SN2. SN1 means rate of the reaction depends on only one species. SN2 means rate of the reaction depends on two species. This SN1 mechanism is called as dissociative mechanism. SN2 mechanism is called as associative mechanism. Is it clear?
Yes, sir.
Now what is that
Yes, sir.
dissociative and what is that associative? That we will discuss one by one. Before that, let me consider one reaction. That's a substitution reaction. Let me consider one arbitrary or random complex as ML5X. For the sake of brevity, I am not representing any charge on the metal ion on the complex also. Plus Y. That results ML5X is replaced by Y now. Plus X. This is our reaction. Ligand substitution reaction. Nucleophilic substitution reaction. Is this reaction clear?
Yes, sir.
Yes. So it is very clear. X which is inside is substituted by means of Y. Then how that substitution reaction may possible? That X is there along with Y is added entry and then removed, or other way X is removed and then entry. Means I have one pen, and in your hand also there's a pen, and we want to exchange the pen. What is the way for, in terms of me, I can give the pen, so I dissociate it. It is dissociate. So now in hand no pen is there, vacancy is there, and then I can take the pen. It is the one possibility. Other possibility, I will take your pen. So in my hand two pens will be there, and then I will give you this pen. So first possibility, I had given pen to you, dissociated. Second possibility, I had taken pen, that's a pen from you, that's association, that's associativity. But I'm talking here now about the dissociative mechanism. So what should happen in the mechanism? Metal is with 6 ligands, 5, and this X is a 6th ligand. This ligand has to dissociate, means this 6 coordinate complex will convert to 5 coordinate intermediate. It is a first step possible. Second step, from this intermediate, I am writing the intermediate again, that is Ml5 plus the ligand which will add there later on, that is Y. Now this intermediate is unstable, 5 coordinate intermediate, 6 coordination is stable. So 5 coordinate intermediate is equal to combine the other, and other is what? Y. So net complex will be Ml5Y. It is a result which was shown here. It was our reactant which was shown here. It is our product. So sorry, reactant, other reactant. It is shown here. It is a product. It is shown here. And is Ml5 and Ml5 will get cancelled as a net reaction. So this is our net reaction, and separate reactions are this one. In first step, there is a breaking of the bond. There is a cleavage of the bond. There is a dissociation of the X. That's one of the ligand. And second step, association. So here two things are there. Two processes are there. Two steps are there. Then question arises, on which factor does rate of the reaction depend? Train is there. Train is with 20 bogies. Consider, train has one speed. What do you think? Speed of each bogie will be same.
Yes, sir.
Other guess I want. Is my question clear? Only one reply I found, therefore I am asking. If no, then say no, I'll repeat my question.
Yes, sir.
So what is the answer then? You have to guess, no? Whether correct or wrong, don't worry about that. When Google recording remains, then who is answering, that will come to know. Now here what? In OBS recording, whatever is on screen, that only will be in record. So nobody will come to know who is talking unless you know yourself. Train is with 20 bogies. Train is going by the speed, say 100 km per hour. Speed of each bogie, will it be same or different? That's the question. Some interest, some imagination will be there, no? You may think something, that only I am asking. What do you think? Will be same or different? Whether correct or not, I am not interested in that. I want to know your view. No, students, as like yesterday you are doing the thing. Only one reply I found. I want reply from others also. Are you there online? Rupashri,
Yes, sir.
what is reply?
Same.
Then who will reply? Poonam,
Yes, sir.
what is reply?
Same.
Vaishnavi,
Yes, sir.
what is the reply?
Different.
Different. Shruti, what's the reply?
Same.
Same. Ganesh, what is the reply?
Same.
Then why you not replied before? Here one student is saying different, others are saying same. Where is the problem? Tell me. Means I should not ask question that exactly I want to know. Why are you not answering? What are your difficulties? What are your problems? Let us solve together. Otherwise you are in problem and unnecessarily I am expecting, then I don't want to trouble you. It is not for trouble purpose, it is for education purpose. It is for feedback purpose. It will help me to conclude the way with which I am going is proper or not. Are you understanding or not? What is your way of thinking? What is your level of thinking? That everything we will come to know. Accordingly, we can prepare our instructions. So where is the problem? Yes, Rupashri, where is the problem?
I am not confirmed.
No problem. But some idea was there. No, you have to answer. You can say not confirm, but this is the answer. That's a honesty. That's a humanity. But if you do not answer at all, then what shall I understand? And repeatedly I am asking. You can say, I think so that the speed of each bogie will be same. Maybe same. Likewise you can answer. Maybe same means not sure. Likewise we'll come to know. Others you have to ask. I am not sure about the answer. What shall I do? You can ask about that. Be clear cut in the communication. Rupashri, is it clear?
Yes, sir.
Poonam, why reply was not there? Suppose if you feel that I should not ask, then tell accordingly. Means we are again wasting our time. Yesterday also the problem same came. Not yesterday actually, before that. Yes, Poonam,
Yes, sir.
where is the problem?
It's a network issue.
Network issue. Miss, have you not heard my question?
I heard, but that screen was freed, so was not able to enable the mic.
Then you can you can say if question you heard, then you can say so screen is not visible, so I can't answer now. Be clear cut in that, so that I will come to know the other problems. Is it clear?
Yes, sir.
Vaishnavi,
Yes, sir.
why answer was not there for this question I am saying? Huh?
Question not clear, sir.
Then you can ask, no question is not clear. I'll repeat. I am repeatedly asking there. But if question is not clear, you can ask. You are free to ask. And chances are there, if I ask question, at the time your network is not there, you will not listen at question properly. Other students might have listened. So for that, each students I am ready to repeat. But you have to ask. Yes, I think Rishikesh has answered. Yes, Alia, what happened? Why answer was not there?
The network went. Now
Now you came. Yes, yes, I know that. Now you are here. Previously you were not there. Okay, but understand if you remain network and if question is asked not clear, then you can say network is not there. Yes. Ganesh,
okay.
what is the problem?
Yes, sir. No problem.
Then why you not answered?
Sir,
Hmm.
answer येत नव्हतं sir.
Then you can say, see, two options were given. See, some logic remain, no? Unless and until you visualize, it is not a by hearting. Train is going, bogies are there, speed is there, no? So speed of that is same or different. That was the question. So there, out of those two, one somewhere imagination should be there. And suppose if you are not getting answer, then you can say, I could not guess. I'm not getting the answer. Means you are not visualizing that I will what understand. If fan is rotating, then speed of the fan, each blade rotates by different speed or same speed. You are going on the two-wheeler, one pilot is there, because a driver is there, and behind that one other is there, friend is there. Then that pilot who is going with one speed and the friend is going with other speed and a bike is going other speed. Is it likewise? So these are the ways by which you can think on the issue. Ganesh, are you following?
Yes, sir.
So I want now onwards, clearly I am saying to all, be communicative. I understand one, two students network problem are there, they are not, I understand. But only one student when answered, then that I can't understand. Is my expectation clear?
Yes, sir.
Yes, sir.
Am I wrong in my expectation?
No, sir.
No, sir.
No, sir.
No, sir.
Only one has not answered now. Rishikesh, are you there in the range?
I answer.
Now question which you asked, have you answered? What was now question that I asked? Am I wrong in my expectation? That was my question.
No, sir.
Yes. Therefore, here you have to every question. Previously, when question asked, at that time you answered, I know. But now, as a feedback, I am asking questions, and there also replies expressed. So be communicative. Certainly, it will help you to know the concept, grow the concept, and to learn the things in the life. Our point of view is the rate of the reaction. Two things are there. Two steps are there. So I asked the question whether the bogies of the train goes the same speed. Actually, engine pulls the bogie. So we find all bogies are going with the same speed. But in true sense, all bogies are not uniform. One bogie may be very new one, newly prepared, new constructed, proper oiling is there, proper mobility is there. And other bogie, maybe the old bogie, maybe 1947, example I am giving, just a student. So other bogie, maybe the old bogie. So in such cases, the bogie which is slow one will determine the speed. As a random observation, we may feel that all bogies are going with the same speed, but few bogies or one bogie is new one, fastly can move, or the same power applied by engine, and other bogie, old bogie. So wheels are not running fast. So whatever the power is applied over there with the speed with which that other bogie is going, this bogie can't go. So rate determining step is rate of that train is determined by slow bogie. Are you understanding this question?
Yes, sir.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
One more example I give it to you. Suppose if I am dictating in your class, I am giving the notes to you. You are jotting them down. You are noting them down. Then do you think everybody's speed of writing is same?
No.
Basically it is not. Basically it is not. But for 1 hour or say for one complete lecture, say for 50 minutes, I dictated, say 5 pages I dictated. Example. Ultimately, whoever students are in the class, everybody wrote 5 pages. So after, as a result, We may feel speed of everyone is same in general point of view, but in true sense that speed is not same. Hello? That speed is not same that you said basic speed of each one is different. But then what happens there? That 5 pages are there, not at once given. Step wise, few words are given or one sentence is given. Suppose one sentence I utter, I inform to you, then you will write. May Rupashri will write fast. Vaishnavi write slow. Example. But what I will do, I will observe that student who is writing slowly. When that slow writer completes the statement writing, then I will give the next statement, next sentence. Suppose Vaishnavi is writing slowly. Then Vaishnavi, as she completes, then I'll give the next sentence. Then again, everybody's speed will be different. When Vaishnavi will complete that, I'll give the third statement. Likewise, statements are given and you wrote 5 pages. Ultimately, from the class, 5 pages are written by every student. But it doesn't mean everybody is with the same speed. Then who has controlled the speed? Who is the rate determining? Vaishnavi's writing is rate determining step. Which bogie is rate determining? Slowest bogie is a rate determining step. So in chemical kinetics, if multi-step reactions are there, then we say slowest step is a rate determining step. Here there is a breakage of the bond. Dissociation is there. And here formation of the bond. That's association you can say. Out of these two, which is a rate determining step, that we need to find out. Are you understanding? Slowest step is a rate determining step.
Yes, sir.
Yes, sir.
Yes, sir.
Now see the complex 6 ligands are there. Here only 5 ligands are there. So what has happened? One of the ligand is removed. Means it is as if like 6 fingers are there. One of the finger is removed. Example I am giving. One of the staff member is removed. Is the first step. Second step, because of that removal, vacancy is there now. Space is there. So when that vacancy remains, one will welcome. So this association is a want of this ML5. Dissociation is not a want of this ML5-6. Means in true sense, desire point of view. But as a matter of chance to completion of reaction, that has to do that. Since dissociation is not easy, this step dissociation will be slowest step compared to this step. So among these two, which will be the rate determining step? This first one will be rate determining step. So we have to focus on this first reaction. So rate of the reaction depends upon reactant, concentration of the reactant. So rate will be directly proportional to concentration of whom? Reactant. Who is the reactant? Ml5X, that octahedral complex. It is a rate equation. Since rate law says that rate depends on only one species, it is called as substitution reaction. Of course, nucleophilic and SN1. Therefore, the name of this reaction is SN1 reaction, or mechanism for that reaction is SN1. Two-step reaction. First step dissociation, second step association. First step is slow, second step is relatively fast. First step is rate determining, and that in first step only one reactants are there. Suppose if second step would have been rate determining, and in case, then the rate will depend on those two things, ML5 and Y. So it will be bimolecular. SN2 it will be, but it is not the reality. Slowest step is a rate determining step, and the number of reactants will decide the order. Actually, it's a molecularity. Order is different. But for simple way, I'm saying it is what the order. Actually, molecularity. So it's unimolecular or one order. Therefore, it is what the SN1. So out of the two substitution reactions, first reaction, that's a dissociation reaction I discuss here. Dissociation reaction, why? Because dissociation step is a rate determining step. It's a very important step. It's a critical step. Therefore, we say that is dissociation mechanism or SN1. Students, are you understanding what I'm saying?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next time we will discuss the SN2 mechanism. But before that, let us revise what have we studied till now. We have studied thermodynamic stability advanced. Now we are studying the kinetic stability or kinetic reactions. Two types of reactions, nucleophilic reaction, electrophilic reactions are there. That's the substitution reaction, the first reaction. Second reaction is, yes, help me. First is substitution, second reaction is
Redox.
Yes, redox reaction. Sorry, here to be substitution. Redox reaction. Their examples are given. Third reaction is
Isomerization.
isomerization or racemization reaction. Here, the linkage isomer, linkage to oxygen, linkage to nitrogen, change is there. Here, cis isomer, trans isomer. Here, actually, isomer only, dextro and leo. But particularly, we can say when equimolar concentration remains, racemic mixture can form. Racemization is possible. Okay, then we are focusing on substitution reaction. Substitution reaction, SN1, SN2, meaning of that, one is dissociative, other is associative. Out of that dissociative that I discuss by this example. First step dissociation, second step association, but dissociation slow step because breaking the bond is difficult rather than when vacancy remains accepting. Therefore, slow step is a rate determining step. So rate law says rate is directly proportional to the concentration of the complex. So this reaction is uni-order or unimolecular SN1. Is the revision clear?
Yes, sir.
Yes,
Yes, sir.
Yes. Do you are in doubt now?
Yes, sir.
No, sir.
Shall we stop now?
Yes, sir.
Yes, sir.
Yes then. Please. Yes. Now lecture is over. Please quit.